Good morning, dear colleagues. I'm Desiree Onamoun from Côte d'Ivoire. I'm a PhD student at the Siberian School of Geosciences in Russia. So today I'm pleased to show you my work, name, result of ground and aeromagnetic surveys for searching for ancient metallurgical objects in the Baikal region in Russia. The use of iron smelting technology marks one of the decisive periods in the history of mankind. In the Baikal region, this technology began to develop more than 2,000 years ago, as evidenced by the artifact associated with it. In order to better understand the story of the development of ancient anthropological metallurgical center research, must be carried out in several stages. Firstly, the main role is played by geophysical methods aimed at detecting such objects. Geophysics seems to be a safe and effective means of conducting anthropological research. Secondly, archaeological excavation of animal-forming objects are carried out, during which samples are taken to establish their age, including oriented sample. At the end, after sample preparation, a set of petro and paleomagnetic studies is carried out to study the physical properties. These data are used in physical and geological modeling of furnaces in order to evaluate the anomalous magnetic effect. The western coast of Lake Baikal, Arkhon, is an ancient mining metallurgical region within which iron was produced on a massive scale starting from the end of the first millennium before our era. So you can see the Baikal region here, and here the site of our research. In this area, at present, more than 70 local accumulation sites of metallurgical slags have been discovered. Ground magnetic exploration studies have been conducted at 25 sites. Archaeological excavations have been conducted at 7 sites. More than 100 occurrences of iron ores of various types have been identified. Now, here I try to show you the designs of iron reducing furnaces. As you can see, here, and here, and you can see the different dates. Iron reduces furnaces from different historical periods differ significantly in design, size, and slag waste. The main search method for ancient iron metallurgy centers is magnetic exploration. Among geophysical methods, magnetic survey play a key role due to the high values of the remnant magnetization vector ion of iron smelting furnaces. It is the undamaged furnace walls that, due to the formation of natural remnant magnetization vectors ion of thermoremnant nature from magnetic anomalies up to several tens of nanotesla. The first magnetic exploration work at ancient metallurgy site in Arkhon region was carried out in 1998. So you can see the result on this map. Excavation of an iron reduced furnace at the Kuma site for petrophysical research. The tasks: selection of oriented sample preparation for the production of cubes, primary petrophysical measurement to obtain values of scalar and vector parameters, and so on. Here you can see how we select the oriented sample from the wall of the iron reduction furnaces. The aim is to obtain the modular and vector values of magnetic parameters, studying magnetic anisotropy and paleomagnetic dating. Here the study of physical properties. As I show on the previous slide, firstly we have the oriented sample that you can see here, then the sample preparation to get the cubes. These are the cubes, and then the different software to get the magnetic susceptibility and the residual magnetization. These are the different graphics which show us the physical properties. For example, here we have the magnetic parameters dependence. Here we have the stereogram of IN and IS, and here we can see the different vector IN, IS, and II. About the petrophysical parameter studies and observation, the selected sample were cut into several cubes with an edge of 20 millimeters, on which measurements of the magnetic susceptibility and natural remnant magnetization vectors were subsequently carried out. The inductive and total magnetization vectors and the Q factor were calculated. The magnetic parameters of the study sample have high values since they experience strong temperature effects during the iron smelting process. The oriented samples of the hot sedimentary rocks are characterized by high values of the vector compared to the II vectors, despite the fact of they experience strong temperature effect. The anisotropy magnetic susceptibility correspond to the sedimentary one. About the location of magnetic and geomagnetic poles based on international geomagnetic reference, we can fix the age of our own size by 700 to 900 years of our era. Here we can see the magnetic pole, the evaluation of the magnetic pole, and here we can see the evaluation on the geomagnetic pole. And the paleomagnetic studies consist of establishing primary component from the vector IN in the process of step-by-step demagnetization by an alternating magnetic field or temperature, and based on the selective grouping of ion vector, a virtual paleomagnetic pole is calculated, how you can see here, and which is compared with the vast trajectory of the apparent migration of the geomagnetic field. And here where you see the star corresponds to is an example of the Kuma on site, which give an age of 700 to 900 years, our Earth. This, you can see some example of magnetic anomalies for ancient metallurgical center near the Kuma River. So you can see the different anomalies on this different map here. The relevance of the study: development of an effective methodology for magnetic exploration studies that allow studying large areas in a short time. One way to achieve this is to integrate ground-based geophysical methods with remote ones to assess the effectiveness of studying ancient metallurgical objects using complex magnetic exploration work, including ground and drone surveys. The studies were conducted in the area of Kuma River on the west coast of Lake Baikal in Russia. The advantages of drone surveying are, firstly, high measurement speed compared to ground-based ones, the ability to take measurements at various altitudes, and it is possible to set extremely low altitude by taking drop survey. The drone is able to independently using satellite data determining the coordinate of measurement points. The technical characteristic of measurement instrument. Here we have the drone server equipment, which is made by our school, the Siberian School of Geosciences in Russia. We have the multi-rotor version of the Siberian Onamoun complex. The survey area is about 3,000 square meter distance between the profile, 1 meter, survey speed 2 meters per second. The magnetic field gradient was measured using two sensors spaced 4.1 meter apart. The distance between the upper sensor and the ground was 8.1 meter. The distance between the lower sensor and the ground surface was about 4 meters. Concerning the ground survey, we use a mobile magnetometer MMPOS-1 designed for high precision magnetic exploration with data storage. Consists of a POS-1 sensor with a sensitivity up to 0.01 nanotesla and a DLPOS data logger. Graduometric survey was performed on an area of 300 square meter over a 1 by 1 meter network. Sensor were installed at a height of 0.5 and 1 meter. These are the results of the drone magnetic survey. Here we have the full vector of magnetic field, and here we have the gradient. So we can see some anomalies here. First one, second one, and probably a third one here. And here too, you can observe these anomalies. Here we have the result of ground magnetic exploration. And this is the area of contrast anomalies. So we can summarize this work like that. Analysis of drone maps of the full vector and gradient of the magnetic field reveal local anomalies up to 5 meters in diameter. The amplitude of the anomaly varies from 7 nanotesla to 10 for the full vector and from 4 to 7 nanotesla for the gradient of magnetic field. According to the ground-based magnetic exploration, local contrast anomalies with an amplitude of up to 30 nanotesla are revealed on the map of magnetic fields anomaly, which are interpreted as effects from near-surface anthropogenic objects. A comparison of magnetic field maps of ground and remote sensing data shows a coincidence in the location of the anomalies. This demonstrates the high sensibility of the method and the ability to detect anomalies associated with near-surface objects. Thus, the result of the conducted research allow us to draw the following conclusion. First, local magnetic anomalies in the study area are apparently associated with objects of ancient metallurgy. Monuments of ancient metallurgy are quite reliably detected using drone surveys, which are much more effective than ground surveys in terms of labor cost. For a more detailed study in the territory and interpretation of the identified anomaly, additional geophysical studies should be carried out over a larger area of archaeological excavation. It is also recommended to conduct experimental and methodological work using a wider range of geophysical methods, including ground penetrating radar survey electrical resistivity tomography, and shallow seismic exploration, interpretation of the complex of ground-based geophysical methods with remote method allow to increase the reliability of solving archaeological problems. Thank you very much for your attention. I will be pleased to answer to your question.